Welcome back to Dr. Liu's VCE Chemistry channel. Today, we are breaking down galvanic and fuel cells from the 2025 NHT Chemistry exam. As I go through this, please feel free to correct any mistakes you find. All feedback from teachers, parents, and students is greatly appreciated. The average oxidation number of carbon in the glucose molecule is 0, while the oxidation number of carbon in the product, carbon dioxide, is +4. The oxidation of 1 mole of glucose involves the conversion of all 6 carbon atoms, resulting in a change of +4 per carbon atom, from 0 to +4. Therefore, the total number of electrons lost during the oxidation of 1 mole of glucose is 6 times 4, which equals 24 moles of electrons. The spontaneity of the reaction is confirmed by consulting the Electrochemical Series. The standard reduction potential for the dichromate ion is significantly higher than that of the iron 3 ion. This potential difference dictates that the dichromate ion will act as the strong oxidizing agent, accepting electrons from the ion 2 ion, the reducing agent. Applying the diagonal rule, or the rule of opposites, to the half reactions yields the overall balanced equation. During this reaction, the oxidation number of chromium in the dichromate ion decreases from +6 to +3 in the product, chromium 3 ion. Because it gains electrons and its oxidation number is reduced, the dichromate ion is definitely classified as the oxidizing agent. The reduction of the dichromate ion to the chromium 3 ion is characterized by a decrease in the oxidation number of chromium from +6 to +3. Therefore, 3 moles of electrons per chromium atom are required to form 1 mole of chromium 3 ions. Consequently, the passage of 1 mole of electrons through the circuit will produce 1/3 of a mole of chromium 3 ions. This mole ratio can then be used to determine the mass of chromium 3 ion produced by 1 mole of electrons. The voltage of a galvanic cell is determined by the potential difference between the cathode and the anode. Consequently, if the cathode potential is fixed, a decrease in the anode potential will increase the overall cell voltage. The half cell B, which currently contains the Fe3+, Fe2+ redox couple, and an inert PT electrode, has a standard potential of +0.77 V. If the PT electrode is replaced by an active iron metal electrode, the half cell changes entirely to the Fe2+ Fe redox couple, which has a much lower standard potential of -0.44 V. Since the Fe2+ Fe potential is significantly lower than the Fe3+ Fe2+ potential, replacing the PT with Fe will decrease the anode potential and increase the overall cell voltage. Cellular respiration, glucose oxidation. The oxidation of 1 mole of glucose to carbon dioxide results in the loss of 24 moles of electrons, calculated from the change in the average carbon oxidation number from 0 to +4 across 6 carbon atoms. Galvanic cell direction. A reaction. The spontaneous direction of the galvanic cell is determined by the electrochemical series. Higher potential species undergoes reduction, which is then used to write the overall redox reaction. Identifying the oxidizing agent. The dichromate ion is the oxidizing agent, as the oxidation number of chromium decreases from +6 to +3, indicating reduction, electron gain. Calculating mass change in Cr3+ ions. For every 1 mole of electrons passing through the circuit, 1/3 mole of Cr3+ ions is produced. This mole ratio is used to calculate the mass of Cr3+ formed. Increasing cell voltage. Replacing the inert PT electrode with an active Fe electrode changes the redox couple from Fe3+ to Fe2+ +0.77 V to Fe2+ Fe -0.44 V. This substitution lowers the anode potential significantly, thereby increasing the overall cell voltage. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.